Today we are going to learn how to create actuated signal control using a VAP file in the Vissim software. It is assumed that you have the actuated underscore 123.vap file, which is distributed by Professor Firth, and you have to complete it to make it ready for using this in the software. Before entering the software, I'm going to explain you. We are going to use the dual ring diagram as it is shown in the screen now, and as you can see, the left ring is for east-west street and the right ring is for north-south street. What is important in this diagram is the number of signal groups. As you can see, the through traffics have even numbers 2, 4, 6, 8, and the left turn traffic has odd numbers 1, 3, 5, and 7. And this is the way the code in the VAP developed to control the signal. Before entering the software, we are going to see what's in the VAP file. This is the actuated underscore 123 VAP file which you have, and as Professor Ford explained, here is the VAP frequency 10 times per second. It will execute the file. The call delay is our constant 2 seconds, and here is our arrays, the variables we defined, and the recall is that I explained you in the dual ring. We have our even numbers on recall or through traffic on recalls, and our left turns are not on recall, and this means that if we don't have any traffic for left turn or any demand for left turn, the software would skip that movements in that cycle. This is the other parts of the code, and this is the incomplete file. You have to complete it and use it in the software. Now that I explain it, I'm going to go to the software and start to create my signal control. For creating signal control, I need to open signal controller from signal control menu. Now I click on green plus sign to add a new signal controller, and the window will open in front of us. First thing, we should change the type to VAP and put the cycle time on variable. Now we need to enter our logic file, which is known as VAP file, and the interstages file, which is known as PUA file. I completed the VAP file and entered it, and also PUA file. The next step is to define signal groups. We need to click on tab signal group at this window, and by clicking on green plus sign, I will add as much as I need. Now remember, we have to use the signal group numbers, which is in the dual ring diagram. In our dual ring diagram, our first signal group, or number 1, is westbound left. I put names for them because I want to recognize them when I want to use them. 2 is eastbound through. After putting name for them, you have to tell the software the minimum green for each signal group. I'm going to choose 10 seconds for our left turns and 20 seconds for through traffic. The final step is to set the amber or yellow time. I choose 3 seconds for all of them. And now we are all set in the signal controller window. I click on OK. After setting the signal control, I'm going to create signal heads in my network. For creating signal heads, I choose signal heads in network objects and I go to the network. I start from signal head 2 because I'm going to explain you how to define signal heads in a multi-lane link. At first, let me explain something. If you notice, when I move my mouse on the link and on the connector, both of them known as a link, but the number is different. The link has less digits and the connector has more digits, 5 digits for a connector number and less digits or 2 digits for a link number. Be careful to recognize them, and this is because if I put my signal head on the connector, only cars that are going to use this connector can see the signal head. But in this link, we have cars that are going to turn right. If I put my signal head on the true traffic connector, the cars that are going to turn right won't see the light and, for example, they want to stop when the light is red. We don't want it to happen. So we should put our signal head on the link that both traffic stream are going to use it and can see the light. Here, as we said, we have signal signal group 2. I chose signal control. The first number refers to signal control. We have only one intersection and one signal control, and the second number and name is referred to signal group. The other things that I don't need to change. As you can see, when I put the signal head, it only affects on one lane. But I want my both lane to have signal head, so I have to create another signal head. Again, this signal head is going to work for signal control 1 and signal group 2. I click on OK. On the same thing, I'm going to create my other signal head. After creating our signal head, our network needs detectors. I click on detector on network objects and we have to do the same thing on the multi-lane. I'm going to show you. I start here, I put a call detector. Remember, the port number is very important. It has 2 digits. The first one from left refers to the signal group and the second one refers to call or extension. The second number or the units number only can be 1 and 2. 1 is for call and 2 is for extension. You can put a name for it. We can define a length. If we have more than one intersection or signal control, we have to choose the signal control. And the other important thing is the location of detector. The first number refers to the location of the first of or a start of the detector at the link. For example, here our link is from west to east, and the 66.105 is the position of the start of the detector. Or we can set a distance for, again, a start of the detector to the a stop line or our signal head. For example, our detector has 10 feet length and I'm going to put it only 2 feet before the signal head. It means that the start of the detector should have 12 feet distance to the signal head. I click on OK and do the same for my second lane. Remember, it only puts detector on one lane. If I want my both lane or the whole stream have detector, I have to put for each lane. The port number should be the same because it only refers to the signal group and the call or extension detector. I click on OK. I do the same for extension detector, and again we have signal group 2 and number 2 refers to extension detector. I will do the same for all of the approaches. After creating the detectors, our network is ready for simulation. Just before running simulation, I am going to change a little bit in my volumes because we are going to see when a signal group is not on recall and have no volume on a cycle, the software would skip it. First, I open my static vehicle route list and I am going to change my westbound left from 100 to 20. Remember, these numbers are relative flow. I am going to change by right click show list on the vehicle inputs. This is my westbound traffic and I reduced 80 traffic for left turn and I reduce it here. Now that I created my objects and my network is complete, it's ready to run. I run the simulation, and if you notice the westbound left movement, it doesn't have any demand and software would skip it. You can see both left turn and through traffic for eastbound are green and the software skipped the westbound left.